Let's write the recurrence relation for the sequence that represents n factorial. And starting from 1 factorial, we have 1, and 2 factorial is 2 by 1, which is 2, and 3 factorial is 3 by 2 by 1, which is 6, and so on. Where the relation for n factorial is given here. So therefore, if we designate this S1, then 2 factorial is 2 times S1, and 3 factorial is 3 by S2, and so on. So therefore n factorial is n by Sn minus 1. So our factorial sequence looks like this. So 1, 2s1, 3s2, up to n by Sn minus 1. So our recurrence relation is n by Sn minus 1 for n greater than 1. And our initial condition S1 is equal to 1. So if we want to evaluate 6 factorial, we have S6 is equal to 6 by S5. And S5 is 5 by S4. And as we can see, S4 is 4 by S3, and so on. So here we're evaluating the factorial recursively from top down. So let's continue. So we have 6 by 5 by 4, and S3 is 3 by S2. And continuing the process, S2 is 2 by S1. And S1 is our initial condition, which is 1. So therefore you get 720. Please subscribe, like and comment to help me reach more students.